Hello, everybody, and welcome to our second day of solving systems of equations by substitution, which is part of our overall study about functions, modeling, and predicting change. And so systems of equations allow us to answer the question of how can I model two or more events that share a common solution. And we do that through systems of equations when two events are occurring simultaneously. The solution is going to be the ordered pair that makes both equations true. So yesterday we began looking at how we could solve a systems of equations algebraically. And we're going to continue that today and continue using substitution. Now, one thing you're going to notice that is different today than from yesterday is that both of these equations today in this system are written in standard form. So I have 8x plus 8y equals a negative 24, and 3x plus y equals 7. Whereas yesterday, one of these was in standard form, and the other was in slope-intercept form. So we wrote down 3 steps yesterday that would help us to solve a system of equations by substitution. And today we're adding 1 step to that. So the first step is going to be to rewrite one of the equations in terms of x or y, which simply means we're going to take one of the equations and solve it for x or y, just like it is a literal equation. So if you need to, let's pause the video for a moment, and you can add that step of rewrite one of the equations in terms of x or y to the 3 steps that you wrote down yesterday. Okay, everybody, so I'm going to take you through a few examples today of how we do these. So if you look back here at the first one, which is 8x plus 8y equals a negative 24, and 3x plus y equals 7, go ahead and write those down on your notebook paper, and I'll take you through the steps of how we can solve these. All right, so when I look at both of these equations, and I need to make a decision about which one I'm going to rewrite in terms of x or y. So when you consider this, you need to consider efficiency as well as number sense. So if I look at both of them, I can tell that it's going to be a lot easier to write the 3x plus y equals 7 in terms of y, or to solve that equation for y, because all I need to do is subtract 3x from both sides. And now I have this equation in slope-intercept form. And at the same time, it is defined in terms of y. So now I can use this expression, which is the value of y, and substitute it back into this equation here. And this goes back to what we were doing yesterday. So I'm going to go and take 8x plus 8, and I'm going to substitute the minus 3x plus 7 in for the y, and all of that is going to equal a negative 24. So now I distribute, and then I combine my like terms here. So 8x minus 24x is going to be a negative 16x plus 56 equals a negative 24. Then I'll subtract 56 from both sides. And now I have a negative 16x equals negative 80. And then when I divide both sides by negative 16, my answer is x equals 5. All right, so I solved the equation for the other variable. Now I need to take and substitute this answer into one of the original equations and solve for the other value. Well, I already have an equation that is written in terms of y and defines the value of y. So I'm just going to take that equation, substitute the 5 in for the x, and my answer becomes y equals negative 8. So my ordered pair solution is 5, negative 8. Now, tomorrow when we do some word problems connected with this concept, it will add a little bit more meaning to what we're doing here today. But what we're going to do today is just continue to learn and to practice the process. Okay? So if we go to the next one, which is going to be negative 2x plus y equals 6, and negative 8x minus y equals 4. Let's go ahead and write those down, and then discuss the best way to solve this one. Okay, so when I look at this, I want to think about efficiency and number sense. So both of these could very easily be changed into terms of y, or solved for y. However, one of the equations would have a negative y and one would have a positive y. So it's going to be much more efficient to work with positive numbers than with worrying about a negative connected to an equation. So this is the one that I'm going to change or solve for the value of y. So I will add 6 to both sides. That way I isolate y. So I have y equals 2x plus 6. So now I have an equation that has an expression, and I can go back to this negative 8x minus y equals 4, and I can use this value of y here to solve for x. So we'll take negative 8x, and we'll put this minus 2x plus 6 equals 4. So what I need to do now is distribute this negative. So that will give me negative 8x minus 2x. Negative times that is going to be minus 6, and all that equals 4. So then I'll combine my like terms here of the negative 8x minus 2x. So that gives me a negative 10x minus 6 equals 4. Then I'll add 6 to both sides. So I have negative 10x equals 4 plus 6 is 10. Divide both sides by a negative 10. And then x will equal negative 1. So now I take that x equals negative 1 and substitute this into the original equation to solve for the other value. So I already have an equation that is written that defines the value of y, which is y equals 2x plus 6. So I will just simply substitute the negative 1 in for the x. Negative 2 plus 6 is 4. So my ordered pair solution is going to be negative 1, 4. And this here will be the last example for the day, and then I will turn you loose on some practice work for yourself. So for this one, I have 7x minus 8y equals negative 2, and x minus 3y equals 9. Okay, so this is a good example, and I pulled this one out purposely of where when you decide what is most efficient to solve, it's not always going to be the y. So I have 7x minus 8y equals negative 2. And then I have x minus 3y equals 9. So if I'm looking at this and deciding which is most efficient for me to use and which one has the best number sense, it would be x minus 3y equals 9, because I can very easily add 3y to both sides and have that written in terms of x, as opposed to the equation above it where I've got 7x and 8y, which means I'm going to have to divide by one of those coefficients, and I'm going to be working with a lot of fractions. So I would rather work with whole numbers and integers any given day of the week than having to work with fractions. So I'm going to take this x minus 3y equals 9, and I'm going to add 3y to both sides. So now I have solved this equation for x, which is going to be the expression 3y plus 9. All right, so now I simply take this expression and put that in for x because that is the value of x. So I have 7 times 3y plus 9. Then I distribute. All right, now when I combine my like terms, you need to remember that this negative is in front of the 8, so I treat that as 21y minus 8y, which will give me 13y, plus 63 equals negative 2. Subtract 63 from both sides. 13y is a negative 65. Divide both sides by 13. And y will equal a negative 5. So now I take y equals negative 5, and I'm going to substitute that answer into one of the original equations. So since I already have an equation that tells me and defines my value for x as 3y plus 9, I'm simply going to substitute the negative 5 in for y, and that will give me an x value. So my ordered pair solution here is going to be negative 6, negative 5. All right then. So again, I've just given you today 5 problems to do. Okay. Very similar to what we did in our examples. So please work them out on a separate sheet of paper. Upload your work to Canvas. Make sure you do all 5 of these. And then tomorrow we're going to do some word problems together that will give more meaning to these ordered pair solutions. All right, so have a great day, everybody. Thank you for listening. And I will not be on Google Meet because of meetings, and I have meetings spread out throughout the day, but you may email me and I will get back to you as soon as possible. Have a great day.